Good morning. I'll be here for some questions if you guys have any. Quick hellos. Good morning, Mad Bloop. Good morning, flambeed cup of noodles. It's a long one. Morning, Joey. I'm assuming, given that that's your last name. Hello, Ronald. We'll start class in about 3 minutes. If you guys have any questions before class, I will answer them. If not, that's fine. But just as a reference in the future, I'll be here. I'll try and make sure I'm on time at about 9:05 to turn on my camera and start talking. So if you guys ever have any questions in the future, quick questions. I won't take up too much time. But quick questions, I will happily answer them before class begins. Morning, Tidy. Am I a morning person? I am a daylight person. I like the sun, so I like when the sun gets up early, then I can get up early. I'm not gonna lie, October through December are really challenging to get up early. I don't drink coffee. I hate coffee. It's evil. But, I mean, this morning I went for a run and shoveled the driveway before 8 a.m. Some people might call that morning. If I wake up past 8, I feel like I'm wasting some of the day. Joey... No, sorry. That's completely understandable. I know a lot of people's sleep schedules have been completely thrown out with the pandemic and staying at home. One of my coworkers, she's like, if I have a meeting before 11 a.m., it's just not happening. Joey, to answer your question, will I be explaining the homework? I'm not going to focus too much on the homework today. I'm going to pull it up and I'm going to talk through a little bit of it. And then we will get at creating a script file, which you will need to do. I'm not going to show you MATLAB grade or anything. I'm going to do that more on Monday. We're going to go through an example homework as part of lecture. And how I recommend you guys approach homework and how you would use MATLAB Grader, how would you submit, all of that fun stuff. So I will give you some information this lecture, but next Monday I will really focus on how to do the homework and all the peripheral reference stuff that you guys have access to. So hopefully that helps. A little bit today, most of it on Monday. Hopefully by Monday, you have some sort of indication on how much effort you need to change things and do for this first homework. Sandwich, unfortunately, no, there's no cheaper way to have access to the textbook. I don't know You can email the textbook themselves. I think it's support@zybooks.com or something, to see if they have any system set in place. Unfortunately, that's the downside of using an online textbook. Joey, if you want to, I mean, it's due on Wednesday, so allocate your time as you see fit. Okay, so it is 9:10. Welcome to everybody, however many people there are. I have it on a different browser window, it's just not open. Let's go ahead and begin. So first things first, let me open up UB Learns. Let me open it. There we go. So notice in week 1, I list out the things you guys should be working on. So you guys should start reading the stuff in the textbook. If you do not get access to the textbook right now, I know some people have had issues accessing the textbook. The material for this week, the deadline isn't Sunday. It's not as soon as possible. The deadline is listed as next week Sunday, which is the 14th. And it will not be sooner than that. And that's just, we typically extend the first set of material just because we know people do have some issues accessing the textbook. So other things, so here's attending lecture, here's a link to Twitch. Notice I put the lectures from Monday on YouTube and linked the videos there. And then today we have a whole bunch of stuff to go through, which each week I'm going to attach the week's notes. So if you click on this, you'll be able to have access. I encourage you guys to download it ahead of time. I will talk through most of these points. Some of it will be linear, some of it won't. I will annotate some of it will be just demonstrating things in MATLAB, and I'll just point back to the notes. But this is essentially your PowerPoint for this class. I converted everything from PowerPoint to notes so that each week you'll have, 5-ish pages that are essentially your review material. So that's your reference. Download that, link through that. That'll be all the fun stuff I'm going to go through each week. And like I said, your homework is posted. I will get to that later. Okay, so let's go ahead and dive right in. So this is what our notes look like. I'm going to go through the first pieces pretty quickly. First things first is we are going to do computer programming. Computer programming refers to the fact that we're using computers. A computer, by definition, is just an electronic machine that processes information. It receives data from the keyboard, from audio, video, whatever it is. It receives data. It stores data in memory. It stores data on the hard drive in long-term memory. It's got RAM and cache memory that does short-term processing. And then it produces output, whether or not that's some calculation, that's some user interface, something that you interact with as the user. So there's a couple components to the computer. There's the CPU, cache and RAM, hard drive, and the path. So the CPU is the main processor, or is the processor. It just performs arithmetic calculations. Cache and RAM, temporary storage memory, and then a hard drive is permanent, quasi-permanent storage system that you have access to. Really, I want to focus on the path, which is typically new to students. The path is defined as where the particular file is stored on the hard drive. So what you have access to. And this is important because we need to know where files are stored in order to use them in MATLAB. So it's a list of folders. So if I go to my Windows machine, on a Mac, you would use Finder. On Windows, you use File Explorer, which looks like this. Whoop. Here's the path. Essentially, it's that list of folders that show up somewhere at the top. So typically you have this PC and you have your C drive. Your C drive is typically your hard drive, and it lists out all of these folders. So going through all of the folders until you hit the file you want. So typically for a Windows, I would go into users, my username, all my files are stored on Box, which is a great idea. Store everything on Box. Store everything on a server somewhere that's automatically saved, because students have lost their submissions, lost their code, lost everything. And it's not backed up. So good idea, store everything on Box or Drive, whatever you use. And then, so I store everything for this class in AAA EAS 230. It's named AAA because then it shows up at the top. And then this semester, for you guys, it would look a little different, however you organize your files. And then I would continue until I find my files. So lectures, I actually don't have any MATLAB code in there. But let's say I'm getting to my notes here. This is the list of files up here at the top. There is a list of folders that I need to go through. That is the path. So if I click up here, that indicates the path to my files. Just some fun background information. Yeah, that's important. That the idea of a path is more important when it comes to MATLAB. So let's jump just basic information about your computer. And like I said, we are going to do computer programming. The goal of computer programming, there's various goals, various reasons why people developed programming. But for us, the main goals are to solve complex, technical, mathematically dense problems, to practice precise, disciplined, and abstract thinking. Like I said last week, not last week, Monday, maybe I said Monday here, maybe I said it at 11:30, I don't know. But computer programming is a different way of thinking. It's not like what you're used to. Most students haven't been introduced to programming. So it's a different way of thinking. So it's an important practice. Even if you never use programming in the future, highly unlikely, but if you never use programming in the future, it is a different way of thinking that's important in our problem-solving development as engineers. We can transform our computer into a powerful tool and then practice for learning itself. Just some basic reasons why we have programming. There are lots of different programming languages. At the core, a programming language is just a set of instructions. So there's a limited number of things we can do that are sent to the computer that tell it what to do. At a fundamental level, the instructions are compiled down into ones and zeros. We don't have to worry about that with MATLAB, which is great. But it's a set of instructions. There's a limited number of things we can do. We can create variables. I'll talk about today. We can do selection, which is branching. We'll get to that, I think, in week 5 or 6. We can do repetition. So we can repeat things over and over and over again. That's looping. We will get to that after we do branching. So there's various things we can do. We can't do anything. There's a specific set of instructions we need to follow in order to accomplish our task. And that's what makes programming challenging. We don't have everything that we can do. We just have to figure out how to take this problem and break it down into those specific set of instructions we have access to. There are lots of different programming languages. Some of the more common ones would be C, C++, Java, JavaScript, Python has like exploded in the last 5 years. MATLAB isn't really one of the most common ones used when it comes to programming as a practice. It's very commonly used in engineering because you really choose a language that's best suited for the application based on its strengths and weaknesses. Python is really great for machine learning. That's what it's been exploding with. JavaScript would be for web development. C and C++, those are more for like if you really want to have extreme control over your memory management and what you can do. Like you could do really fast applications there, or also embedded design. If you can read my handwriting, I will try to be a little bit clearer as we go along. But if you can't understand anything, please just tell me that, oh, that wasn't written clearly. But so you use the programming language that best suits your application. We are using MATLAB because MATLAB is a computer software and programming language used to perform engineering and scientific calculations. It inherently defines things as a matrix, which is really useful for complex calculations, for optimization, makes it easy to do linear algebra, which is commonly used in engineering applications, specifically in your guys' fields. Not all fields, but most students who take this class. The nice thing about MATLAB is it's nicely packaged for us. So we can you just literally double click that icon that MATLAB gave you, and it's nicely just integrated all there. We can see our code, we can run our code, we can visualize our code, all of that fun stuff right there. It's also cross-platform, so you don't need to worry about which operating system you have, which a lot of other languages are too, but they're not nicely packaged. The main useful thing that we have that's really useful to us is that MATLAB is weakly typed and an interpreted language. That means that we can access it really easily. We don't have to go through a bunch of behind-the-scenes stuff. We can type a line of code, run it, see what happens. Okay? And then also MATLAB has a lot of predefined code. That's where your toolkits were. Those contain a bunch of what's called functions that we can use to do some really complex things without having to worry about actually writing the code ourselves. We can take advantage of the fact that someone else who's a little smarter than us already put that together. Okay, so that's just some basic background information. So let's go ahead and start programming. Let's start doing something. So I'm gonna go ahead and open up MATLAB. Like I said, to open up MATLAB, you just double click that MATLAB icon that you have. It'll show up looking something like this. So there's a couple windows here. You'll notice they're named. This first one here is my current folder. This is literally your file explorer or your finder, whatever operating system you have, it's your folder system. You can navigate through your folder system up here. So notice you can see the path here that I'm in the C drive, the users folder. Here on this computer, instead of on my laptop where my notes are, my username is Emily Hammond, and then in my documents, and then all of you guys have a MATLAB folder that was installed when you downloaded MATLAB. Okay, so you guys all have this. This is the path. These are the files that are located in this folder. And that's important because these files are the ones that we can interact with, the ones that we can use when we are writing our programs. The second thing you'll see here is the command window. The command window is essentially just a type as you go. It's a place where you can you can write lines of code one at a time. We'll get to that. You can see what happens. And there's a lot that shows up in the command window. It's really a reference that we can work with. And then over here on this side, we have our workspace. Our workspace shows all of the data that we are going to be working with. The data is stored in something called variables. So it shows all of our variables, all the data that we can use in our programs. Another window that you might find useful would be something called the command history or the editor. So if you ever want to change the way this looks, you'll just go to layout. These windows are each separate and you can change the way they're rearranged. So you can go to layout. Here's the default layout. You can do a 2-column layout where you put your workspace over here. You can do your command window only. Maybe you might want to do that. All but the command window minimized, where you can pull out these windows if you want to. And then you can also manually rearrange things as well. If you just click on the blue bar for each window, you can literally just click, drag, move it around. So you'll see me change things up quite a bit. It really just depends on your preferences. I think my beginner layout looked something like this. But you guys can always move things around. If you want to use the MATLAB online version, same idea. MATLAB Online has some frustrating things, like it restarts every 30 seconds if you don't use it. But it's the same idea. Same thing looks like this. Current folder. This is your command window. Here's your workspace. You can change the layout. There's less here, less options, but it's the same thing. You might also want to see the command history. If you just go to layout, you can see command history. You can say docked. Command history shows everything that you've typed in your command window. And that might be useful, and I'll kind of show using that a little bit. If I wanted my command history to disappear, I can click this button up here in the corner and I can just say close. Same thing, if you click this button up here, there's lots of different things you can do. One last thing I want to mention in terms of rearranging this current layout, you can click on this and you can do what's called undock. And now it's completely separate. You guys can't see it anymore. But now it's completely separate. It's essentially a separate window that's not associated with MATLAB. It's not inside of what's called the MATLAB desktop. If you want it back, you just re-click that arrow and say docked, and now it shows up back. Okay, that's just some basics. These windows are all really useful. However, the main window you guys are going to interact with is called the editor. So the editor is where you are going to write your script files and all of your homework. In order to open a script file, you just click New Script up here in the corner. When you do that, it's going to pop open the editor window. And then you have a file that shows up, and this file is called a script file. It's where you're going to write, modify, save, all that fun stuff, all of your code you can write here. So when you start your homework, you would open up the script file, you would type whatever code you need to write for your homework, you would save it and submit this file. So this shows up in the editor window. I'm going to do some rearranging just because I have some preferences on the way I like things. So here's my current way that things look. Okay? You have your preferences, you'll figure it out as you go along. And the more you interact with MATLAB, the more fun and cool new ways you'll figure out to do things. And that's the general basic on interacting with MATLAB, the program itself. On our notes, I have useful commands written down. I'm going to come back to those, and we're going to actually start writing our first set of code. So it doesn't, Ronald, it does not matter where things are located. It's really just, do you know what each of these windows do? It really doesn't matter where they're located. That's completely independent on what they do. Natchev. So there are something called a live script. We are not going to work with those. Those are more for tutorials. You'll see them online for tutorials. Do not worry about live scripts. We are only going to work with scripts. Okay, that's a good question. Ignore the live script. Only do scripts for this class. Okay, so let's write our first program. So I'm gonna just do some typing. I'm gonna type the program that's in the notes. So it starts with mass equals 1400, velocity equals 30, and KE equals 0.5 times mass times velocity squared. So right now, our programs are pretty much just gonna be doing mathematical calculations. So there's a lot here. Let me go ahead and step through what's happening. Okay, first things first is we have this statement called mass equals 1400. So we have a word, an equal sign, and a number. This is called an expression. And I'm jumping around a little bit in the notes, but just because I want to make this as practical as possible. So this is called an expression, which means line 2 here where it says vel equals 30, word, equal sign, number, that's also an expression. Same thing here. So note, an expression is a combination of variables, which are just words that show up on the left-hand side, followed by an equal sign, followed by whatever shows up on this side. Okay? It can be a combination of numbers, which you guys will do a lot of what your first homework is, just writing out a bunch of numbers. And then also we have a bunch of different mathematical operations that we can do. So let's talk about variables. Like I said, variables are just these words here. A variable is actually something called a memory location. You can think about a variable as a container. It's actually a physical place in memory, but really just think about it as like a box that's going to store some data. I have some variables here. My illustration variables, like I said, they're containers, so I have some mason jars that I'm going to use as an illustration of variables. So variables are just memory name locations that identify some data that's stored somewhere in memory. Think about it as a box. This box called mass here currently stores a value of 1400. This box called vel here currently stores a value of 30. This KE box currently stores whatever this expression is, whatever this calculation is. Okay, so a variable is just a box. That box has a name. That name here is mass, this name is vel, this one's KE. There are some rules in naming our boxes, naming our variables. We can only use letters, we can only use digits, we can only use underscores. And then keep in mind they are case sensitive, and they need to start with letter. So I can't have a variable of 3 stars. Just made that off the top of my head. This is invalid. I can't start my variable with a number. I also can't have spaces. I can't say 3 stars. And MATLAB will show you more or less whether or not things are invalid. Note when I said 3 stars and did space, MATLAB showed this red. This red indicates there's an error. Errors show up along the side here, so I can see, oh, there's a parsage error at stars. That means something I'll talk about on Monday. But it says, hey, there's something wrong here. Same thing here. 3 is completely valid, but this isn't included. It thinks that this is something different, so it shows up in purple. Okay? There are a couple different main ways to name variables. You can name them, really, you have freedom to name them whatever you want, as long as they're composed of letters, numbers, and underscores. But there's 2 basic naming conventions. One is camel case, where you have no spaces, because you can't, and then each word that you have is capitalized. So if I wanted a variable called number of people, I would just say number of people. So you can easily see here that it's the word number squished together with the word of, squished together with the word people. And oftentimes variables are pretty long. You want them to be descriptive. You know here that this variable will store the number of people. This one stores mass, this one stores velocity, and you might guess that KE stores kinetic energy. But I could rename this and say kinetic energy. It's more descriptive. So this is camel case, where each word is capitalized. Now the second one is snake case, where you just replace spaces with underscores. So these are snake case. Sandwich, that's a really good question. You cannot use symbols. So just letters, numbers, underscores. That is it. So you can't do period, you can't do slash, you can't do question mark, anything like that. So this is snake case. And to be honest, you typically use a combination of both. It's really up to you. You kind of get a feel for how you name your variables. Everybody typically has their own style, but those are the 2 main things. The last thing is there are certain words that you can't use. They're keywords. So these are the different keywords in MATLAB: break, case, catch, class def, continue, else, else if, etc. You cannot use these to name your variables. So I can't have a variable named global. And MATLAB will show you more or less that is a keyword or something you can't use. It'll typically be a different color. Most of the time it's in blue. Okay, so you can't start a variable with a number. So you can't do 8 people. Like I said, MATLAB will give you an indicator that that's incorrect. You could do people 8. That's valid. So if you have, so that's a good question, Mad Bloop. Variables are case sensitive. So that means if I do mass equals 14 and then mass equals 1200, these are 2 different variables. So spelling is a common error. Typically, you want to try to spell everything correctly. There's no spell check in programming, which is unfortunate. There's no spell check. So if you say mass here, and then you say capital mass here, you're going to get an error because you've defined a variable called lowercase, M-A-S-S, but here you're using a different variable called capital or uppercase, M-A-S-S. So spelling is a common error. A lot of times, well, let me see what happens. Now I'll show you guys what errors happen when we have spelling errors. Okay? But keep that in mind, there's no spell check in programming. You need to type your variables the same every time. Variables are case sensitive, so capital variables are different than lowercase variables. So keep that in mind. And then but best practice is, like I said, you really want to use descriptive variable names that identify what type of data they're going to store. Like I said, they're just containers. It's just a container. So you want to name it, you want to name your container an indicator of what kind of data it's going to store. So if it's just storing a number, maybe you just call it num. Maybe num1, maybe a different one would be num2 or num3. So it's really up to you. Some of your variables in your homework need to be named exactly the way I tell you to name them, but most of them you're going to have freedom to choose whatever you want. So a core piece of programming is creating variables and storing some data in there. So the way we store data into a variable is using this equal sign. So you might think about this equal sign as equals in math, like x equals 5. That means x is always 5. In programming, it's different. This equal sign is something called the assignment operator. It's used to assign data or values to my variables. It's used to put data inside of this container. So if I have this container, it's named mass. This equal sign is saying, hey, I want you to store the value of 1400 inside this container. So if I had a variable called num equals 9, because I have a 9, if I called this variable num, it would say, hey, take this 9, my child's number magnets, and store it inside this container. If I had a different variable, var equals 2, here I have a different one, call it var, store a value of 2. That means I'm going to put a 2 in there. Okay. So now I have these two variables, one called var, one called num. Num stores a 9, var stores a 2. So it's just used to store data in there. If I said var equals 9, or var equals num, let's see if I can do this. Sorry if that's loud. So now I'm saying var, even though var stores a 2 at this line, at line 2, var has my 2 in there. If I then say var equals num, that's essentially saying, hey, take the value in var, throw it out, and replace it with the value that num stores. So I would take another 9 and drop it in. So now at line 1, I just have num. It stores my 9. Shoot, I need that number. At line 2, I have a variable called var, and it stored a value of 2. And then at line 3, that 2 completely disappeared, and now stores a value of 9. So now I have two variables that store a value of 9. So, trigger happy Eli, interesting. That's a very good illustration point where you wrote var plus num equals 11. So yes, in math, that makes sense. If I took the 9, hold on, let me find my 2. Let me find my 2. Where did it go? That's okay, I have another one. I forgot, I have another one. So yes, so if I took the value stored in var and the value stored in num, if my num stored the 2, I would get 11 if I added them together. That's in math though. In programming, you can't have an expression like this. You can't say var plus num equals 11. Like that's not how programming would work. it would give you an invalid indicator. What you would do is you can only do something like this. New value. You can only say variable equals. So you can't have anything where you have it backwards. It always has to be variable equals something. You can't say variable plus variable times another variable times a value divided by value equals something. It always has to be a variable equals, and then whatever data that's going to store would go on the right-hand side. So now the value stored in new value would be 11. It would automatically do the calculation for me. It would take the value 9 here. Let's say that wasn't there. It would take the value in var. It would take the value in num, and it would do that calculation and store that new value inside of this variable. Okay, so Natchev brings up a really good point. Where the values stored in variables are going to change throughout your program. You expect them to change. You want them to change. So in my num equals 9, my var equals 2, and then if I said var equals num, like, I mean, you guys saw me throw that 2 away. I can't find it. It is somewhere in this room. That's essentially what happens when you have variable equals a new value. That 2 completely gets thrown out. It's inaccessible. It is gone somewhere. It is completely gone. You have no access to it anymore. All you know is that that value now stores a 9. So if you are swapping values, if you are swapping variables, let's say I want num and var to switch values. I want num to store the 2 and var to store the 9. So I can't just say var equals num, because that's going to completely get rid of my 2 and replace it with a 9. So now I have 2 9s. And nowhere do I have the indicator that there was a 2 somewhere. So what we need to do typically when we're swapping values is we need a third variable that's some temporary variable. So now I would say temp equals something. Let's say temps equals var. This is where I need my second 2. Now let's say temp equals num. I have 2 9s. Okay, so let me figure this out. So I've got my num equals 2, my num equals 9, my var equals 2. And then I say temp equals num. So that means temp here, num stores a 9, so it makes a copy of the 9 and puts it inside of temp. Note it's a different 9. So now both temp and num store a 9. Now I can say var equals, or I can say num equals var, and I can take this 2 that was in var, I can take this 2 that was in var and make a copy and store inside of 9. So this 9 disappears, and now I make a copy of this, and now this has a 2. So now both of them would have 2s. I just lost my other 2. So now num stores my 2. I'll just put that 2 in there. So now num stores my 2. Which means that var, if I want it to have that 9, what I'm going to do is I'm going to take my value from temp and copy it into var. So now I copy my 9 and put it inside of var. So now temp. So now temp and var have my 9s. So keep in mind the values inside your variables are going to change. If you say var equals 2 here, later on and you say var equals temp, that means the 2 completely disappears. You have no access to it anymore. And now var is going to store your new value, whatever temp was. So if you say num equals 9, that means at line 1, num stores a 9. Later on, num is going to store whatever var stores. So in temp, so in this example, I use temp because I'm illustrating how to do it properly. Previously, I was just showing that your 2 disappears and goes away. So Sarah Barrow Why can't you just go back and change the original numbers for bar? You can. You can. So we have complete control over how we write our code, but a lot of times we don't want to sit here and modify it all the time and rerun it. A lot of times when you're writing code, you've got thousands, hundreds, in some applications, millions of lines of code that you need to run together. When you open up Microsoft Word, you don't want to go sit there, fiddle with the program in the background in order to make some minor changes. So we want to make sure that we program things so that when we press run, automatically things go on in the background. And that's part of the trouble. That's part of the struggle of writing code, is figuring out what you want to do manually and what you want to do automatically when you press run. Okay, so we talked a little bit about variables. We talked a little bit about expressions, not much. But let me delete this. And here's my original code. So if you write your lines of code, you write however many lines of code you want. Let me put my glass jars away. Hopefully that wasn't too loud. Sorry about that, if it was. But I've got my original program, and now I want to actually run it. I want to actually execute this code. So it's not just enough that you have to write it in MATLAB, you also need to run it. So to run it, you go to the Editor tab, and then you literally just press run. It's so nice, so simple in MATLAB. So simple compared to other languages. In order to run your code, your file needs to be saved. So here, I'll call it my first program 2. So the first time you run your code, you just need to make sure it's saved. If you are on MATLAB Online, you need to manually save it first. For some obscure reason, the run button on MATLAB Online is not directly tied to saving it. I don't know why. But you just press run. Note, when I saved this file, it showed up in my folder. It showed up here in my current folder as my first program 2, because that's what I saved it as. So that means if you open up your File Explorer or Finder, it will also be in this file, in this folder. Okay, so a couple other things to mention. Note, I have 3 variables that I have in this program. Notice those 3 variables show up in my workspace. So does ants, but don't worry about that right now. Kinetic energy, I can see as a variable, and I can see its value. It stores a value of 630,000. Mass stores a value of 1400, and velocity stores a value of 30. Note, there's no units associated with these numbers. They're just numbers. Your computer doesn't know units. Your computer just knows numbers. It is your job as the programmer to understand what is happening behind the scenes. So what we can do, typically, is use comments to help give some sort of context. So a comment, shows up in green, and it's anything that's written past a % sign. Jada, I don't know why you would have trouble saving your files. That might be a problem with your computer. You should be able to just save them directly. You can always go to save as. So if it doesn't save automatically, you can always go to save as over here. You should always be able to open everything. You can also interact with like you normally do with files over here. So that if you're having trouble saving your files, that might be a problem with your computer. But try a couple different options. Go to save as. Try some different options. But typically what we do is we use comments to help give some context. So this program here is calculating kinetic energy. As you may have guessed, but it's just good to give some context. And I can make it more specific. Energy, in the notes, it says energy stored in the car driving on the highway. I can indicate what units these are. So mass is in units of kilograms here. Velocity is in units of meters per second. Units are important, even in programming. You need to make sure you're working with the right units because your program, unless you tell it to, isn't going to know which units you're using. And then this here, energy would be in joules. So comments can help give us some sort of context. Okay, so they're really useful. So anything that shows up past a percent sign shows up in green, that indicates it's a comment. Note, I made some changes to my file. If I look up here at the name of my file, there's an asterisk next to it. That means I've made some changes. I need to resave my file, and then I can run it. So anytime you make changes, you need to rerun your code. On MATLAB, if you open up the program, if you just press run, it will automatically save before it runs. MATLAB Online, you need to save it manually for some obscure reason before you run it. Sarah Barrow, you can't open up other windows within the new script. I don't quite know what you mean by that. Ronald, you cannot. So if I write a comment and then I try to write var equals 12, that's not valid. It will completely ignore it. So typically we write comments either on lines above code or after lines of code. That's a very good question. And you'll notice because MATLAB shows things up in green. It's really useful. Okay, so let me finish up today talking about this side of our equation. So, Sarah, that's a good question. So the editor is completely separate. You press run, and then you use these other windows to interact with the script. So you can see over here in my script file, whenever I run it, it types out the name of the program that I ran. So I ran this file. So command window shows everything from my first program. Workspace, current folder. If you want to ever change your layout, go to home, layout, and choose one of these. So home, layout, default. So it goes back to the default, which you see here. Does it look like this? Is it just literally just the script? Okay, so layout, default. Go to layout, choose default. You can also double click this top part here and it will make it smaller. So I double click this, double click that. Oh, I gotta get my layout back. Okay, so let's talk a little bit about this side. So on this side, so remember it's just variable. No, you do not need to see ants. Ants came from something else. I'll talk about ants in a minute. Or maybe I'll make a video on ants. So that's an error from what I typed here. Don't worry about that. Okay, so remember I mentioned it has to be variable equals and then something. So this something is at right now, it's just a bunch of math. There are a couple different math things we can do. We can do multiplication using the asterisk. So you have to use the asterisk for multiplication. You cannot do multiplication without asterisk. You can't just say 0.5 mass. That will give you an error. So if I ran this code, notice over in my command window here, I get red that shows up. Red indicates there was an error with your program. It tells you there was an error in this file, line 4. This is a hyperlink here. So if you click on it, it will take you directly to where the error is. And then it says invalid expression. Check for missing something. So here, what I'm missing is a multiplication symbol. Okay, so you need to do multiplication every time you mean to do multiplication. You can also do division. I could divide just using my normal backslash. There's two different types of division. Right division is this one, left division is this one. Right now, only worry about right division, the normal division. Left division we will get to in a couple weeks when we talk about matrix math. We can also add things with addition and subtract things with subtraction. Those are all the fun math things we can do. Oh, and exponents. So this is velocity squared. Okay, so it looks a lot like how you would type things into your graphing calculator. Another thing we can do is we can use something called built-in math functions. Let me go back to our notes. At the last page in the notes, you see a table of common math functions that we have access to. And I will give an example of these more on Monday. And you can work on them with your homework. But anytime we see e raised to the x in our math, so if I had 10e to the 15, in MATLAB, I would type 10 asterisk exp 15. So a function, here it identifies what my MATLAB function looks like. So if I want to calculate e to the x, I would type the word exp followed by open close parentheses and then whatever value my exponent was. Same thing for all of my trig functions. So sine, just like you would in your graphing calculator, you would type sine. I mean, really, you wouldn't, but you would type the sine. But in MATLAB, you would type sine, open close parentheses, and then whatever you want to calculate the sine of, whether or not that's a specific value or a variable. If you want to do it in radians, so here's if you're in radians. If you're in degrees, there's an additional letter. You just type a D after sine to indicate that you want to calculate the sine in degrees, or that your argument, this value is in degrees. So if you want to say 5 sine of pi times e raised to the x, where x equals 2. In programming, you would type x equals 2, and then you would say your calculation, let's say it was y equals 5 times sine. If you want to do pi, you can literally just type pi. MATLAB already has that stored in there. And then you would multiply it by exp x. So now this value of 2 would be used here, and it would do that calculation for you. So it looks very similar to the way you would type it in your graphing calculator. Keep in mind, it follows the order of precedence, so parentheses, exponents, multiplication, division have equal precedence, and then addition, subtraction have equal precedence. Okay. And I will talk about functions next week. This is just a brief introduction, but next week we are going to explicitly talk about script files and about functions. Okay. Just some final notes to talk about. There are some pre-existing variables that exist in MATLAB. So like I mentioned, pi, it's the value of pi. So anytime you need to use pi, you just say type pi. You don't have to import, everything is already inside of MATLAB. You don't need to import math like you would in Python. Ants is the default variable. If you don't type variable equals something, if you just type this something that's valid, MATLAB will automatically store it in a variable called ants. Okay? That's why you saw ants in my workspace. I typed something in my command window, and that's why I didn't store it in a variable, so that's why it was ants. I or j, both of those are the imaginary number. INF is infinity, and NaN is not a number. Most of the time, we don't really use those, unless you have a specific application. Other things to note, some useful commands. So let me go back to MATLAB. Notice my command window is full of stuff here. So you can technically type lines of code in your command window. I can say var equals 12. Var now shows up in my workspace, stores a value of 12. I'll get to you guys' questions in a minute. So you can type things in your command window. If you ever want to just kind of refresh your command window, essentially delete everything there, you just type CLC, press enter, and it will clear your command window. Another thing is if you want to delete all of the variables in your workspace, let's say you are done, you want to refresh everything that's in here, you would just type clear. Note, you can always get your variables back by rerunning your code. So I rerun this, and now kinetic energy, mass, and velocity show up. You can also change the way things are output in your command window by using format. I will get to format more when we actually print out numbers. And then lastly, diary might be useful as well. It can record everything in your command window. We're not really going to use that. I have used it. I do use it when I write your auto grading scripts to grade your homeworks. But you guys can look that up using the help resources in the video that you'll see on Friday. Okay, so that is all I have for today. I got through most of it. There's still some stuff that probably needs clarification. I will create your videos, or you're gonna watch some videos on Friday that hopefully clarify some of writing scripts and some of functions. But that will show up on Friday. There is no class on Friday. Shoot, I didn't go through the homework. There is no class on Friday. I will post videos. I will send out an email. The homework is posted. A lot of it is just doing calculations. So you would just create P1A and you would type out that calculation. Most of it is numbers. We're just getting you as practice for essentially doing mathematical operations in MATLAB. Like I said, on Monday next week, I will more explicitly go through how to write those expressions, how to submit your homework, more explicitly on how to put together a script file. Today was just an introduction to MATLAB itself. And then your homework is posted. It is due next week, Wednesday. So 1 week from today, it's due at the end of the day. So you have until 11:59 p.m. to, well, technically midnight. I'm not going to mark it late if it's 11:59, 10 seconds. Or 10 milliseconds, whatever. So you have until the end of the day in order to do it. Okay, with that, sorry for going a little bit late. I'm still figuring out the pace on Twitch and all of that fun stuff. There's so many more questions compared to like being in the classroom, which is awesome. I'm glad you guys can ask them. So I will stick around a little bit longer if you guys have more questions. Other than that, keep in mind or watch for my email and the posted information for Friday. Have a great day. So Joey, you can change the layout by going to, let me show MATLAB again. Go to the home. So up at the top, you have all of the different tabs. Just go to home, layout. You can choose whatever layout you want. If you want to manually change it, you can click and drag each window to wherever you want it to be placed. And you'll get used to it as you play around with it. Or just pick a specific layout. But you'll get used to it as you play around with it. But right now, just the default layout should be fine. Jada, I'm just using those first 4 letters. So the square brackets mean something different. You can only use parentheses in your mathematical expressions. So you can't say, I just want to do this first. That is incorrect. MATLAB will give you a warning. And it means something different. Your brackets mean something different. We'll get to that in week 3. So the editor is, Tidy, I'll answer your question in a minute. The editor is where you have code that's saved. You type it, it's saved. You can close this, so I can save this, I can close it, I can reopen this program, and all of my code is still there. The command window is essentially a scratch pad, is what Dr. Ali calls it. You can type lines of code, so I could say mass equals 1400. Type that there. Any output from my script file will show up in my command window. It's essentially, it just shows up stuff. Errors show up there. But this all goes away. Like if I say CLC, I can't really get that code back unless I retype it. So it's best to use script files unless you're just doing some basic problem solving in your command window. Tidy, trying to install MATLAB on your main computer, but keep getting an error on installation. I don't know. It's hard to figure that out without actually seeing your computer. Try Googling the error or contacting UBIT. They might have a better indicator and could potentially meet with you. It's hard. Okay. So Sarah Barrow. I only have editor published view. What do you mean by editor publishing view? Even if you go change your layout, are you working with the MATLAB program, like you double click and it opened? And when you access layout, it won't change for you? So we aren't going to actually touch Simulink. MATLAB's just fine. So Sarah, is your editor completely separate? Like, is it completely outside of MATLAB? Okay, so there should be a little arrow in the corner like this, that when you click down, you should have some options. I don't know why they're not showing up. You should see minimize, maximize, undock, close. If you click, or dock, you should see dock. If you click dock, it should show up back inside of your MATLAB window desktop. Ooh, really, Joey? Whoa, fascinating. See, you learn new things about MATLAB all the time. So, Natchev, if you have a specific question, try going to office hours, which you don't have access to. I will email you the link for office hours. I think the TAs might be starting right now, or Dr. Ali has office hours all day. I'll email you the link, and then you can go to office hours. Typically, I have office hours after class. I didn't expect people to start working on stuff so quickly. So Joey, the other way to find your command window is going to layout, command history, and say docked. Like I said, for some reason it doesn't show up for you guys, but click layout, down to command history, click docked. And that's where it shows up. Sarah, did you figure everything out? Are you still here? Okay, awesome, perfect. Okay. Everyone who's left, have a great day. Feel free to email me if you have any questions in the future. Like I said, office hours start next week. Jada, the Monday's lecture will help you more with the homework. And the videos. The videos will help some. Okay. Have a great day.